can make my screen visible to share my screen.
Interesting.
From
Are you logged in as a presenter? Means I'm not. I don't know how the GoToMeeting works.
yeah, I used it one day when Neeta was here, and it was fairly simple. The menu just dropped down from the top, and I just clicked. Oh, that was WebEx. Okay.
Yeah.
So I'm not able to do this thing, and today I think Neeta or Snigdha are there, I think, right?
Hold on. If you are logged in as a presenter, you should see it.
No, I just clicked on the mail that they had sent me with the link, and when I clicked on that, it came to it says link for Big Data Hadoop. There is a link for webcam, share my webcam, but there is no share my screen.
Okay.
Yeah, you can see the webcam, right?
Yes, I can see your webcam. And
but I don't know how to.
You are an organizer because you were able to turn off my camera.
Actually, from this machine, I can't see. I can just see. I can just see GoToMeeting, the main screen, and then it says connected to GoToMeeting, and then it says get your own GoToMeeting or that or whatever. And then on the left-hand panel, I can see show your control panel. Then it says you are muted by the organizer. Then it says no one can see you, share your webcam, and then it says full screen mode. Right now it's H2K Infosys is the presenter, but they had made me the presenter, but I think now because of this problem they took back the thing again. Now it says presenter H2K Infosys. Now it doesn't say the presenter. Where is the chat window? I don't see any chat window. No, nothing is minimized. No, nothing.
Restart the machine.
I closed the entire Firefox and then restarted again.
Restart full machine.
So you want me to shut down the machine and start again? Yeah, I closed Firefox and then I restarted the whole thing again. We even restarted our modem so that we thought maybe there's something wrong with that.
You want to leave the meeting? Yes. Okay.
Hello?
I'm not seeing any chat window here.
Do you see an orange arrow on the right side of your screen or left side of your screen?
There is one screen that is coming up that shows. Jumbo, can you bring this up? That's all testing microphone, Jumbo. That's not sharing the.
And I have disconnected you.
Okay, and you're.
Okay, now it's coming here.
No, can you go to meetings? Oh, it just says.
Okay, fine.
No, where is the?
Wait.
Audio not good. She's saying you can see a chat window. This is the only one. It says go to meeting viewer. And in the viewer, do you think the chat window will be there? Pull this thing on. Pull this. So to call them and ask them because I can't see a chat window.
Let me start for another machine. Can you transfer your things?
I closed go to meeting and started again. This will be the fifth time I'll be doing it. meeting ID or anything. We're just taking the meeting ID. We're just taking the meeting ID from the link itself. Okay, all right. So now it's saying launch application. Citrix Online Launcher. I'm launching the application. But you know what? It's just saying you have a session already running. You cannot join another session at the same time.
That's right, because I can hear you. You never logged off from your current session.
Yes.
Encourage
one of
you.
the milestones you print your name and everything you see will keep track with us. So you can just see yourself on the connect.
So I'm not seeing the window itself. I'm seeing a waiting to view H2K Infosys screen and that is not the tab window, right? Okay, the guy is calling me. Hold on, okay? Hello? Yeah. Yes, Vamshi. Yes, Vamshi, I can't see that place where I can make myself the presenter. No, I mean, I can't share the screen. Huh? I joined Aditi Datta.
We can see your screen now. Hello? Hello? We can't hear you. Hello, you on?
Can you hear me?
Yeah, we can hear you now.
Okay. All right. All right. Hi, everyone. I'm Aditi. And I'm so sorry that the initial setting up, there was some problem with the initial setup. I'm very sorry, and I'm very, very thankful for you guys to be patiently seated. I'll be talking to you about our new course that H2K Infosys is planning to offer, the one that you are all here to hear, that is about big data using Hadoop. Let me get my white screen. Just bear with me. I had all the initial setups ready, but then because of this problem, they all went away, and I had to close all of them. Anyway, Like I said, our topic today is going to be on big data using Hadoop. And H2K Infosys is planning on starting this class as soon as possible, along with the other numerous other classes that they have. And the instructor for this course is going to be me, Aditi, and my husband, Jayant Datta. A couple of lines about us. I'm a consultant with a company called Artsoft, and my husband is a veteran in software. He's a technical director at a big data startup company in the Silicon Valley here. Oh, by the way, we are from California. Okay. With that, let me go to my actual slide. Here, I welcome you all again to H2K Infosys. It is a e-verified business based in Atlanta, Georgia, United States. They provide online IT training services worldwide, and their website is h2kinfosys.com. The number to reach them at in USA is 1-770-777-1269. And their email address is training@h2kinfosys.com, or you could even reach them at h2kinfosys@gmail.com. Now, the courses that H2K Infosys offers are many. They are 100% job-oriented, instructor-led. Face-to-face courses are also available through online live training. The courses that they offer provide in-depth syllabus with latest technologies, real-time project work to gain hands-on experience. You can practice your work on their cloud test lab. H2K Infosys provides you with recorded class videos for lifetime access. You can go back to those videos and listen to them whenever you want to. H2K Infosys organizes mock interviews for you to help you do well in the interview sessions. They organize group discussions, and they help you with professional resume preparation and resume reviews. Finally, they see you through the final stage of getting a job placement. So they help you with job placement also. In short, H2K Infosys is trusted by many students worldwide. Now, a very important instruction while attending online classes is that we would request you to use headsets and microphone for the audio part, or you could even use phone to dial the conference number with the attendee ID. However, for better audio clarity, we suggest that you use the headset and the microphone duo. That keeps your hands free. You can write or type or do whatever. Okay, and also please mute your phone and microphone for better audio clarity. All right. So the agenda for today is to introduce you to H2K Infosys, talk about us a little bit, discuss what Hadoop is and why is the big commotion for Hadoop nowadays, why big data using Hadoop is a hot career these days. Then I'll talk to you about the curriculum that we have planned for you, and also why you should consider taking this course at H2K Infosys. Why H2K Infosys has a competitive edge over other institutions offering courses like these. And finally, a few words about the schedule of this course. So H2K Infosys is an e-verified business based in Atlanta, Georgia. We provide Hadoop training along with lots of other trainings to our customers, both on-site and online. We also provide job placement assistance. Assistance while the candidate is on project. H2K Infosys is proud to boast of a clientele such as General Electric, AT&T, Dish Network, Wells Fargo, Verizon, Sony, Bank of America, and as you can see, the list is a huge one. We have a big background of great names. So H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals. They provide special IT training for MS students in the United States. H2K Infosys provides software design, development, QA manual automation, performance testing, and maintenance. H2K Infosys provides IT staff augmentation, job placement assistance, and technical support. The courses offered by H2K Infosys are QA testing, performance testing, advanced courses in automation testing and performance testing, business analysis, Java J2EE, Microsoft .NET Technologies, data warehousing, SAP module, Oracle SOA, and as you can see, the list is a long one down there. Now we introduce a new course, which is currently very hot in the market, that is Big Data using Hadoop. And I'm here to talk to you about that. Now let's talk about Hadoop. Now, why is this fuss about Hadoop made these days? It all started with us getting overly technology dependent. We share photos these days. We upload and download lots of pictures. We send messages. And all of that creates huge amount of data. I read somewhere that a few companies like Yahoo, Facebook, Amazon, and a few more like that generate about 30,000 gigabytes of data every second. Now, this data is not useless data, I mean. Companies are using this data. And what are they using it for? They are using it to create analytics. And what does that mean? It means that they are using that piece of information to understand the user's trend. Meaning, for example, let's say they're trying to by going through the weblogs, they're trying to find out how many people are visiting the Macy's men's apparel page, let's say, or how many people are actually buying when there is a sale event. So they're using this data that we are generating, this huge amount of data that we are generating, and they are using it for their benefit. And based on that, they are going on they are spending on their advertisement, they're planning on their advertisement and things like that.
Okay, so it's very useful data, and so then we have to find a way to store that data. Now the traditional database systems that we have had is not capable of doing that. Like I was just saying, the data that is being created is of the order of gigabytes, terabytes of memory. It needs that much. And our existing systems are not capable of handling it. We have tried increasing the memory strength of our machines and making them more and more powerful. But how much powerful can we keep on? How much more memory can we keep on adding to accommodate this amount of data, right? So that was a problem, and that is why we had to come up with a different system. Now let's take this example that I have on screen right now, in which I'm trying to go through a file, and I'm trying to count the number of words that there are in that file. Let's say in this case I am handling just a line for simplicity of explanation, but you can extend this and think of it being a huge data. Okay, so here what I'm trying to show you is that what I can do with a small amount of data is going to be very hard when the data becomes big. Now when the data is small, things are very simple. I have one small data, and I run a program on it to count the number of words that are there in it using a program. And then as a result of the output of that program, I find that there are 2 do's in the input. I find that there are 2 as's in the input. I find there are 2 I's in the input, and so on and so forth. There's 1 not and 1 say. This is pretty simple like I said, if the data is very small. But if the data becomes big, then we end up having lots of problems. Here, again, I try to emulate that process and show you that the data is stored in the underlying file server, and there are lots of computers working on that data and counting the number of words that we input, and the result from each computer is coming to one machine which is doing the final aggregation. This is how we are doing the work now, and this is working fine because we can store the current data in this file system, because current data is not huge. But the problem arises because of certain factors. Now let's see what those factors are. One, the data is stored in a different place in our underlying database system, and the data has to be pulled from there by the program and has to be worked on by the individual programs that are running simultaneously in parallel. So pulling the data through the network is going to take up time, and it's also going to eat up the bandwidth, and it's going to make the system slow. So that's problem number one. So problem number 1 is slow. It's going to take time to pull the data in order to work on it. Second problem would be that all these computers which are running in parallel working on the data set, they are going to send the result to one computer. And that computer has to do a lot of work. Now what if the output from each individual computers that are working on the data, the results from that, if that is very big, so big that this computer cannot handle it, then we have a problem. Also, if this machine fails, the one which is doing the aggregation, if that fails, then the entire result is lost. There's a lot of dependency on this. So the new system that we had to come up with in order to use the big data had to solve those problems. And so Hadoop was made to solve these problems. So here in this chart, I have listed down the major challenges that we had been facing and how Hadoop has solved those. And that's why Hadoop has become popular. We'll come to that later though. Now the first challenge that the traditional systems were facing is that the size of the file was huge. The size of the data file was huge, and we had to store those data files. Remember, I said we are creating data at the rate of about 30,000 gigabytes per second. So the data file that we had to store, the companies wanted those data, and so we had to store them. And there is no way of doing it right now. So what Hadoop did was pretty smart. They didn't keep the data in one place. They distributed the data. They split the data into multiple bits, multiple packets. And they also made it fault tolerant by replicating the data, making sure that no bit was lost. No split was lost. And that is done by the part of Hadoop, which is called as the Hadoop file system. The file system stores the data in it, but it stores it in a distributed and replicated way. So there is one problem solved. Second one, in order to, when we were trying to store the incoming data, what we were trying to do in the traditional system was that we were trying to add memory upon memory and trying to make our computers more powerful so that they could store the incoming data. Of course, that had a limitation that the computer's motherboard had to permit that. But we kept on increasing it as long as it was permitted by the design of the computer motherboard. But that was becoming very costly. As we had to keep on increasing the memory, it was becoming very costly. But by the time Hadoop came up, the hardware companies had actually made up optical disk-based hard disks, which were cheap, and multiple of those computers using those type of disks would be started being used in Hadoop clusters. These were actually called commodity hardwares. Commodity computers. Okay? So economic optical disk-based hard disks started to be used. And of course, it has to be cheap. If we have to keep all those data, but we have to pay a huge price for it, then the companies don't want to do that. They want it cheap, right? So Hadoop became an economical solution to their need. And so it was accepted. Third problem that the traditional systems were facing was that the critical final aggregation had to be done on a single machine. Remember the single machine that I was talking about? The one that did the aggregation from the other machines which were running the program. That final aggregation was dependent on the single machine. Hadoop found out a way to overcome that too. It distributed the computing. Not only did it distribute the data like we were talking earlier, it distributed the computing. So the program started running in parallel over multiple computers. So that way, we didn't have to depend on one single machine. Lastly, high volume of data had to be transported from the file servers to the computer that was doing the computation on the data. So data, like I was saying earlier, the data had to be moved from the file systems to the computer. And that was taking up time, that was eating up bandwidth, causing a lot of problem and making the system slow. Hadoop came up with a solution for that too. What did it do? What it did was very, very smart. It didn't pull the data to the task like it was being done by the traditional systems. It moved the task, which was smaller, to the place where the data resides. Data was kept and it remained and never moved from the computers where it was stored. So that is what is called as data locality in Hadoop. Hadoop promoted data locality. Data remained in that exact locale, and the task which was going to work on the data moved there. That made it faster. To work on that amount of data, it became faster. And so now you see, we came up with a system, Hadoop came up with a system that can solve our problems of doing some kind of math on the huge data that we are generating now. So what exactly is the formal definition of Hadoop? Sorry. Hadoop is an open source computing framework that supports the processing of large data sets like we have today in a distributed computing environment. It has a reliable, fault-tolerant, distributed file system, and high volume of data can be processed with ease by using parallel computing. Its MapReduce development infrastructure enables us to read, write, and perform basic aggregation-like operation on the stored data in batches. Now, what does this all mean? Saying this in simple terms, Hadoop is an open source computing framework. Okay, so it's open source, anybody can work on it and contribute to it. It's a computing framework. We can do math on the data, okay, that supports processing of large data sets. We can work on large data sets using Hadoop. And the way it works is that it distributes the computing environment, meaning it distributes, the work is distributed among different machines. It has a reliable fault-tolerant file system, distributed file system. That is what is called as the HDFS, like I said earlier. So Hadoop's file system is reliable because data is never lost. It's fault tolerant because it replicates, and it handles high volume of data. And its MapReduce infrastructure helps in doing the computation on the data. It helps us enable read, write, and perform basic aggregation, as the sentence says. So these two are the underlying two technologies related to Hadoop. Now, parallel computing is a basic underlying thing in Hadoop. Now, parallel computing is not anything new to us. We always use parallel computing in our daily lives. For example, in factories, in the assembly lines of factories, people work in parallel to complete a job. At home, if you want to clean our house, for example, and if every member of the family works together and work in parallel, they get the job done faster, right? Now, I want to draw your attention to one particular example that I'm fond of, which is, give me a minute. Which is about the voting system that our society has. And I choose this example simply because it's very easy to understand MapReduce, because MapReduce works exactly the same way. Our voting system is a classic example of parallel computing. Now, if you let's say candidates A, B, and C are running the election. Now, when it's time to vote, different people go to different polling booths. And cast their vote there. And voting happens concurrently, simultaneously on all the polling booths. When the voting time is up, the polling officer or whoever counts the vote, he or she counts the vote given to candidates A, B, and C on each polling booth. So you have polling officer working on the first booth, polling officer working on the second booth, polling officer working on the third booth simultaneously, and they count the number of votes that candidate A got, candidate B got, and candidate C got. And they declare a result and say that candidate A has this many votes, candidate B has this many votes, and candidate C has that many votes. Now this happens simultaneously in multiple states. And when all the states have gone through their voting process, then they aggregate all the vote that candidate A got from state 1, 2, 3, and so on. Candidate B has got from state 1, 2, 3, and so on. And candidate C has got from states 1, 2, 3, and so on. And finally, they do the aggregation and come out and find out what is the total amount of vote that candidate A has got, candidate B has got, and candidate C has got. And based on that, they decide who is going to be the head of the state. That's exactly how Hadoop works as well. Let me erase this. Give me a minute. Now in Hadoop, there would be a client who would be submitting a job, and it would go to the Hadoop system. One would be the name node server, which takes care of the data and which has multiple nodes under it. And these actually store the data in it. This is the part where the data is taken care of. The name node and the data nodes take care of the data part. And there is also the computer which takes care of the computation on the data, which takes care of the job, called the task tracker. That's the main computer, which also has multiple nodes under it. Because remember, the job is also distributed in Hadoop. Not only is the data distributed, the job is also distributed in Hadoop. And that is taken care of by the task tracker. And it has multiple nodes underneath it. This one is the job tracker, and these are the task trackers. Okay, so as you can see, this Hadoop, in Hadoop, the data is split into smaller parts. That is done by this server and is stored in multiple computers. Those are those servers, those machines. And then the job is run on each of these computers in parallel. And that is happening on this side of the picture, where the job tracker is taking up the function of splitting the job, and then the job is run in parallel in these machines that you see down here. And as a result, from the final result is sent back to the job tracker, and the client can see it. Now, you'll wonder why Hadoop is so popular. As you can see, Hadoop has actually overcome all the problems that our initial traditional systems were facing. And that is why there is so much demand for Hadoop these days. Because most companies are moving towards Hadoop-based solutions these days, the number of jobs related to Hadoop is on the rise. And that is why learning Hadoop is going to benefit you. Now, these are the job openings that you often see in the job market for related to Hadoop. They ask for Hadoop admin engineers. They are the people who administer Hadoop. They take care of the cluster, how many, I mean, if anything goes wrong with the cluster, if any commodity hardware, any commodity computer were to die or crash, they would replace it, change it, and make sure that everything goes on smoothly, there'll be no downtime, and so on. So that's the Hadoop administrator. The Hadoop development engineer is the one who programs, who does computation on the data that is stored in there. So he should be the one who should know programming languages like Java. They should be able to use SQL on the data and some scripting language. And some related technologies like Hive, HBase, Pig, and all that would help him accelerate in his career. The Hadoop Big Data Architect is responsible for the actual planning and implementation of all Hadoop-based solutions. So he is like the mastermind. He decides which technology to use, how to find a solution for the problem that the company is trying to, how to integrate Hadoop and find the solution. Basically, that's what his work is. Data scientists work mainly on the data. Their work is how to read the data from Hadoop file system and figure out solutions to it. Now, the course that we will be offering will touch base with all these positions, and you can decide which one you would like to apply based on your interest and skill. Now, as you may be aware that it is big data is currently very hot in the job market, and it's expected to grow to about 14 billion by 2017. Now, I would like to take this opportunity to actually show you some of the jobs that are currently available in the market. Let's go to my web browser. Okay, here we have Indeed.com. And if I just put in Hadoop over there and ask them to find the number of jobs, you'll see that there are over 8,000 jobs in the Hadoop area worldwide. And if you scroll down, you'll see the different types of positions. Okay. Now let's see another one. This is usarecruit.net. If I type in, same way, if I type in Hadoop and ask them to find the number of jobs available, again, they come up with 8,586 jobs. Now, Simply Hired, if I do the same, I'm just trying to show you the number of jobs available in the market these days. They come up with a number that's almost double, 16,194 Hadoop jobs in the market. So what I'm trying to tell you is that What I'm trying to tell you is that the requirement is huge. There are not so many people in the market who are experts in this field. So people are scramming, people are learning, and this is actually a very good time to switch your field and jump into this area. Here again I have some other names for job searching sites. And on the right side I have some names of companies which are looking for Hadoop people. Now let's talk about our syllabus. To attain proficiency in this area, we have made a very elaborate course. We are trying to keep our course to around 30 hours, including some mock interviews in it and some group discussions with review of resume and all that. We'll be providing basic Java and Unix introductory courses for people who are not very confident on those topics. Then we'll talk about Hadoop. We'll introduce Hadoop. We'll talk about the Hadoop architecture. We'll help you install Hadoop onto your machines. Now talking about that one, I would say that if you have a Mac, it's going to be easy for you to install Hadoop onto it, because Hadoop works on Unix and the underlying OS in Mac is Unix. But however, if you are having a Windows machine, it is not it's not that you can't run Hadoop on it. What you will have to do is you'll have to install a VirtualBox of some kind, and then inside that VirtualBox you will have to put some kind of Linux, Ubuntu Linux or something, and then in that we will run Hadoop for you, or rather you will run Hadoop and we'll help you. Then we talk about uses of Hadoop. Then we go down to the main section, which is MapReduce. We explain how MapReduce works. We talk about the story behind it. We move on to show you MapReduce development. We will show you a program and explain how the program works, the different parts of it, the hows and whys. And then finally, you will write a program. Or actually, you'll write more than one. All right. And then we'll talk about unit testing on MapReduce using MR unit and also, if you have time, Mockito. And then we'll talk about how to customize MapReduce using different types of key values, using custom key, custom value in your program. Then next we talk about the input and output format, where you, it's not just that you can analyze text files, but you can also analyze, let's say, XML data, or maybe binary files, or even if the file it's streaming data. So different kinds of input and output format, we talk about that. Then we talk about Hadoop I/O, different algorithms that are used for MapReduce, how to administer Hadoop clusters. Then we talk about the next version of Hadoop, the next improvement that they have made in Hadoop, that is Hadoop 2.0. And certain technologies that are used in the Hadoop ecosystem, like HBase, Hive, Pig, Impala, Storm, and so on. Here you see the detail of the of each individual topics that I was talking about. In Hadoop architecture, we'll talk about how it is made fault tolerant, how HDFS is HDFS as the file system works, and all that. The same thing that I was talking in the previous slide. This is just a detailed version. I was just saying it there, and it's all written out here. You'll be given hands-on exercises, like I was saying, for MapReduce when under the topic MapReduce hands-on. You'll be using custom key composite keys. You'll be using custom value class for customized MapReduce. So you see, we have a very detailed syllabus planned for you. These are the advanced topics. The last few sessions will be on these. Now, one question that I want to separately address, I know I said this while I was going over the syllabus, and the question that often comes back to us is that is it important to know Java in order to know Hadoop? And is it necessary to know Unix? Well, I would say that you have to know a little bit of Java and a little bit of Unix to feel confident and be able to do work on MapReduce comfortably. But if you don't be disheartened. Like I mentioned earlier, we do have a session which talks about in which we introduce these two topics, Java and Unix, and we'll teach you that part of Unix and Java that you will need in doing your MapReduce, in writing your MapReduce programs. So as you can see, the syllabus is very ambitious, and we are both very excited to start the course. So please enroll as soon as possible. Get in touch with the coordinators as quickly as you can. Call H2K Infosys at 1-770-777-1269 or email them at h2kinfosys@gmail.com. Once again, their phone number here is 1-770-777-1269.
I have a few questions, if you don't
Yes, yes.
I think the 30 hours duration is not sufficient at all. I think you had to bump it up at least because this is like an integration of Hadoop is 30 hours. I think you need, as a trainer, and honestly, you should know, and 30 hours is not sufficient at all. You need at least 40 to 50 hours. And I think it's
the question is.
Yeah.
Hold on a minute. Yeah.
Hi.
Yeah, he says that 30 hours is not sufficient. We need at least 40 to 50 hours. Yes, but the main focus of this would be on MapReduce, and the peripherals will be just introduced, and we'll just give you a head start on that. As for the details of each of those parts, we'll have to, like you said, we'll have to split it into a second course or third, and give you in-depth knowledge on that.
And the effort. Okay. So it will be really then costly, and major participants will decline to join. That biggest is one issue I have seen. To be competitive with other providers, we need to then cut down a little bit. There is no other way. Quality is also directly proportional to money.
Yeah, but you can talk to HK. I can understand, like, you'll be charging X amount of money, etc. But
yeah, so that's why we thought of breaking this into two parts, wherein we could get people interested and they would come in and they would get the basic, and then we could move on and take it one step further based on how many people came, and you get what I'm trying to say.
Yeah. Yeah.
I mean, I'm not at the end of this course. I'm not saying you are going to become this. Yeah, exactly.
Give you the working knowledge so that you can do by yourself if you are interested.
And then we can take it to the next step.
If you want to really go for it, then we'll have to coordinate another advanced detail level course where various kinds of difficult problems, more hands-on, because these are all more if you practice hands-on, more you will learn. There is no way escaping this route. But major, the other companies when they provide, they cover most of the topics. Then somebody will ask, why your course is not covering this amount? Why do you need, say 2 months rigorous training? People will not understand that is not the inefficiency. So it is the participants' tolerance, participants' perseverance, so many things are involved in this.
Yeah, but as a trainer, it's not a 30-hour course. It's easily 45, 50 hours. I can understand. You can split it, but I think H2K should offer at least 40 hours.
We'll talk to the organizers of H2K to actually do the market study actually, what actually the participants need. We may think something that to be competitive, but that may not be always the success story. So it depends on the actual participants also. So your feedback is very important. Please convey this to H2K Infosys either directly or via us.
Yeah. And
All right.
One more quick question, if you don't mind. Like,
Yeah.
I'm an integration guy. I'm a middleware integration plus a solution architect. So,
Okay.
so how much will the switch time? Like, so I'm switching to Hadoop. So I know a couple of guys who makes good money in New York City, pretty good money. So my question is, so what are the risks? Like, what are the chances I can quickly integrate? Like, I have some background. I have around.
What kind of integration service you are doing? Are you doing in the Microsoft environment like IIS or say?
No. I am actually I'm worked with IBM. I manage around 600 JVMs around. Around 19 major applications we support, Bank of America and PNC. So when IBM on infrastructure, so when a new concept is taking place, so we go in with POC and then provide them what are the tools as its integration team, performance-wise, application-wise. When it conceived, we give them a kind of a hands up. So my role is I have a lot of exposure to Unix, Java. I'm not a Java developer, but
so your job actually involves a lot of technology stack to explore.
Yeah. So conceptual level.
You are actually one good candidate for pursuing this kind of profession where every new technology stack is added on.
So you think the switch won't be that much of a tough, because I don't have any exposure to Hadoop. I know, I've been reading a lot. Few weeks, but
yeah, but I think the switch should be easy.
Yeah. So because you quickly are adapting many technologies. So for this field, I think it will be easier for you because you can touch.
Is it something ideally somebody who has a lot of Oracle background?
Oracle background.
No.
I don't.
Backend database.
Okay. Oracle is basically MySQL, SQL stuff. And people do. Oracle doesn't mean just Oracle. Somebody writes JDBC programming. Somebody writes. The other kind of PL/SQL. There are different kinds of skills people do. Somebody does DBA. So who does DBA? Audit, system.
Okay, so what is it NoSQL? Do you guys be clarifying on that?
Just
Yeah.
Hadoop, the most popular one, which actually is in production by many companies, like the HBase. We are planning to add that course. It cannot be included here. There is another,
Okay.
Huge thing.
lot of stuff. So we were willing to do that. Even the easier part like Hive, say another very fast programming. The scripting is the key.
Big, yeah.
They are like touching Uzi. So Uzi, will at least take maybe 20 hours to give really good experience. So these all will need time and good.
I mean, if you have to go into depth of each one of them will be one course on its own.
Yeah, exactly. Yeah.
So that's why that was the last thing in the syllabus, where we just introduce you to what they are. The main focus of this one is just Hadoop with its MapReduce. HDFS and MapReduce is the main focus of this.
Unless you have more than say 2 years of experience, you should try doing that kind of program, say 600-700 lines of programming just for hello world. So you will find why the hell we are doing this. So those kind of things we are not pumping in the jargons.
Yeah.
So
we'll just one step at a time.
Those ways then we'll add the NoSQL stuff, obviously.
Okay.
The HBase will be the second target, and after that, the Hive in that chronology.
Yeah, I get the better idea. Yeah. So somebody with the average background, like so what is the expectation in the market? Like somebody is a newbie, so how are his potential, like as a Hadoop consultant? Say for example, as a
newbie. It's for a newbie.
Yeah. See, I joined this course and do a 40-hour course, and then I do my homework properly, and then what are the chances for us to sneak into a project?
That's the development actually,
and it'll be
like
yeah.
ETL job, like data transferring. So
yeah, he can move into that field easily.
So that is the easy part for you actually. Say for data ingestion from many companies are trying to
move
from conventional data storage like Teradata, okay, or say Oracle. So they want to transfer
to Hadoop.
Another part is actually will be discussed later on from the structured data.
But is it expensive? Like the implementation part could be very expensive, right?
No, actually not. Actually not.
It's not that costly to
implement. Because like I was just saying, it uses lots of mid-range type of computers, and they are connected in parallel.
Yeah.
And if one dies, you just throw that away and bring another one. And
the OLAP-like service, like aggregation service,
where
you have used data. So mainly one kind of activity you are trying to process. Say I want to find the maximum, the say
salary
number of maximum salary within this state, okay, within this age group. That kind of information if you try, then that huge data if you try to execute on Oracle or Teradata like environment. First of all, proprietary environment you have to go on paying. Then the other thing is those servers, and they need powerful servers. You will spend on hardware a lot. And another thing is the fault tolerance. Hadoop comes with the very robust the data availability is called. So always you will be sure that you will get the data if you query, and that will come very fast.
Yeah.
And it can handle the unstructured data. You don't need to write the schema, and if you want to change the schema, then execute alter, put some default values, then sometimes performance goes bad, you run the statistics, reorganize the data, truncate, those all problems will go away. You don't need to do any update or delete operations, just go on story.
Okay. Okay.
The technology, most of the file systems I am expecting will be changed to Hadoop. Like operating system will work directly on Hadoop. like Microsoft Windows may use the file system HDFS. That is
Hive is Apache application, right?
Hive is, on the top of Hadoop, you add another metadata store so that Hadoop can be used for querying using the SQL statement.
Okay.
So, and it slows down a lot because for every piece it requires one MapReduce. So directly, if you use Hive on the top of Hadoop, you will not get the performance. You'll have to use stays in between that so that Hadoop directly is not accessed by Hive through tails. So that is the solution people are now trying to implement. There are other products like Impala that does much higher performance SQL query on the top of Hadoop.
Okay. All right. You're right. Thanks for your time.
Okay. Great.
No problem. You're welcome.
Any more questions?
Anyone else?
Okay. I think everybody has.
Yeah, when do we anticipate the course to start?
Beginning of April, yeah.
And do we have any idea of what the schedule is going to look like? Is it going to be two days a week or everyday courses?
I'm not 100% sure. It would be nice if you would talk to the H2K Infosys coordinators for that.
Okay. Is this your first course with H2K?
With H2K, yes.
Okay.
For others, actually, not for
Okay, thanks.
Thank you. Anyone else? Any other question?
I think we're done. Is anybody there?
Hello?
You can check.
No, I guess we're good.
You're good? Who is this? Vamshi?
No, this is Kishore.
Oh, okay. So do you see any H2K coordinators there?
Hello? Vamshi.
Hi.
Vamshi here, Jayant.
Hi. So it looks as if they have no more questions. Ask them if they have any more questions, or else we can call it a day.
Guys, if anyone has any questions, please discuss with the faculty. And the rest of the things, okay, so please call to 770-777-1269 so that we can help you the better, okay? Okay, guys?
Okay then.
So thank you very much, guys, for
Okay,
joining
thanks.
the class.
Thank you. Yeah, thank you all for coming.
Bye-bye.
Call H2K and sign up.
So many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website h2kinfosys.com. On our website h2kinfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more